Well, hello, and here we are, and we'll take up one more problem. This is fundamentally an inequality pertaining to geometry. So let's try. So it says that given triangle ABC, AM is the median, and so first of all, what I'm going to do is that I'm going to cheat a bit because first of all, I'm going to make the circumcircle. You can read the question for yourself. So, given a triangle ABC with the median AM is the median, D lies on BC after C, and AD is twice of CD, and the circumcircle of a triangle AMC meets AD at N, and then this is the proof that something of that is true. So first of all, what I'm going to do is that I'm going to cheat my way into the problem because it's difficult to first uh, make a triangle and then make the corresponding circumcircle. So I'm rather going to make circumcircle first, a triangle later. So this is my A, this is M, and the median AM, or rather, let's be B. Let's be M. Uh, AM is the median, so AM is the median, and so since AM is the median, so it must be somewhere here. So this must be ABC. These are equal. Uh, the circle and so diagram is a bit incorrect. So first of all, I'm going to shift this entire thing. So in fact, they're supposed to find the circumcircle of AMC. So if it's AMC, come to this part later. So B must be somewhere here. B, and it must be such that that BM and MC must be equal. So the point lies on the point D lies on BC after C, such that AD is equal to 2CD. Such that AD is equal to 2CD. So AD is equal to 2CD, like something like that. And the circumcircle of AMC uh, meets the segment AD at the point N. Right, like something like that. And so what do you have to prove that BC plus AM is in fact uh, equal to BC plus AM is greater than 2MN. And this is MN, by the way. Right, so the question which I'm asking of myself is that it's given, what's given that AD is equal to 2CD. There's something that we know, right? And the question is that is this just a coincidence that uh, the number two features here and two features here, or is it by design? So I'd like to argue, or I'd like to, again, I'll say that this is a part of wishful thinking. If you have uh, seen the last video, then it's also part of wishful thinking that need two is by design. So the two there and the two here must have some connection. it's entirely possible that they might not have connection. In that case, we'll be pursuing a false lead, and which is absolutely fine. But generally, the idea is that I try to think in this way that if there is something that you have been given, it must have some bearing on the given problem, right? Okay. Uh, all right. So first of all, BC, BC is not nice actually. So I'm going to just say that BC is 2MC. So I'm going to rephrase what we have to prove, that 2MC plus AM is greater than 2MN, or AM is greater than 2MN minus MC, right? So, and this is nice because if you look at this MN, this is MN, this is MC, and we immediately see that they are the sides of a triangle MNC, which means that I must join this line, right? So I must join this, right? Yeah. Okay. Uh, Now what I see is that if you have a look at this, then it's almost trivial to note that we can use part of point thing. Well, dn into ad will be equal to cd into cm, md rather, right? And what we know is that this number is twice this number. So what does that tell you? That tells you that this number is twice of this number. So you get md is equal to dn. In fact, twice of dn. Okay, let me tell you what my thought process is at this point. So what we have seen is that we have to essentially prove that AM is greater than this. Okay. And well, MN minus MC, what's MN minus MC? What we know is that in fact, I'm going to the next page. What we know is that MN minus MC is less than MN minus MC is less than CN. So 2 times Mn minus Mc is less than 2 times Cn, right? And if I can further prove that either Am is equal to this number or Am is greater than this number, then we are done with the problem. Uh, Either Am is equal to this number, so this number is equal to Am, that will be done with this problem. Or we can say that if we can prove that Am is greater than this number, then this will follow, right? Are we clear about this? Now, it's not typically difficult to see that, in fact, this is true that AM is in fact 2 times CN. How come? Well, similarity. Have a look at this. So look at the diagram. AM CN is a cyclic quadrilateral, and that would essentially mean that this angle is equal to this angle, and that would essentially mean that this angle is equal to this angle, and this angle being common. So you see that something nice has happened. Two triangles have become similar, and one side of that triangle is CN, the other side of the triangle is AM. So what you get is that, well, triangle DCN is similar to triangle DMA, or rather triangle DAM. And so what you get is that DC upon AD, and that's equal to CN upon AM, and we know that CD upon AD is 1 by 2. Right? CD upon AD is 1 by 2. So that tells you that 2 times Cn is equal to Am. So, well, this number is equal to Am. So Am is greater than that number, and we are done with the problem, right? So that was that.